Okay, so I'll be talking about photogrammetry workflow and how you can use Houdini to make your life a bit easier working with photogrammetry. I try to be pretty quick. The weather is pretty hot. We all want to drink a cold beer after, so I think it will be like 20 minutes presentation. But let me just quickly introduce myself. I work as in FXTD here in Paris, mostly at Unity PDG. I started working there like 4 years ago, and I started to use Houdini 5 years ago, and now I'm also teaching Houdini in some schools here in Paris, including the school hosting the event today. So hi to my students here. And on the side of that, I'm also passionate by 3D scanning since I started CG. I also work at Scan Engine, which is a 3D scanning studio here in Paris, created by Unity PDG. At first, it was for in-house projects only, but then we started to work for other clients. And recently, Unity PDG worked on an episode of the Netflix show Love, Death and Robots. And every member of the Unity team have done an amazing job on this show, and Scan Engine delivered the character and facial and body scans that were used as a base for the character modeling. Actually, my friend Xavier Petron at the very back of the room was the scan supervisor on this project, and he's done a very nice job. So, okay, how photogrammetry works. I'm pretty sure a lot of you guys already know how that works, but just as a quick reminder, you need to have multiple pictures of the same subject, but shoot from different angles. The first step is feature detection. So the software tries to find interesting points in the pictures. And after that, you have the structure from motion. So it tries to find matches between the features from all your image. And from these matches, it can estimate like camera and feature position. The next step is the depth maps computing. So this one runs on the GPU. It's like the really intensive task. It can take multiple hours to reconstruct the depth maps for each photograph. And once you have the depth maps, you can now build a mesh and then texture it. So that's a really quick overview of the whole pipeline. The software you have on the market, actually there are a lot more than that, but I'm only talking about the one I already use in production. You have reality capture. I think that's maybe the most famous software today. Basically, if you go to their website, there is a huge banner saying we are 10 times faster than anything else on the market, and it's actually true. So if you want to try, you can give it a try with reality capture. Then you have adjustive metashape. It's a bit older one. That was a standard before SE came up. And the last one I selected is Alice Vision. This one is a bit different because it's an open source project from the French company Micros Images here in Paris. And so yeah, it's free and open source. Obviously, it's a bit slower than the other ones. But it's really built with the VFX production in mind. So feel free to give it a try. The good thing is that in Houdini, thanks to the game development toolkit, you have a reality capture plugin, so you can run all the scanning pipeline directly inside of Houdini. You also have the new Alice Vision sub that wraps the open source Alice Vision project. And since 17.5, you have like the new top networks, so you can wrap anything with a CLI, basically. So Metashape or the CLI version of reality capture, if you want. So I'm gonna go very quickly through the different steps of how do you start with like input photographs and then you end up with a production ready asset. Because it's not as straightforward as the classic photogrammetry pipeline where you just reconstruct the mesh, build the texture and voila. In reality, you need to have a lot more steps to have already a quality asset at the end. Okay. And we will see how Houdini can help at each step of the pipeline. So first step is shooting. You'll need sharp and clean pictures, so you have to use a low ISO number on the DSLR. If you use high ISO, it will introduce noise in the image. So it will produce noisy scan, and the worst case scenario is that the feature detection will grab features inside the noise, and then bad things happen. You need like fast enough shutter speed and small aperture to make sure everything is really sharp. And so you need a lot of light. And obviously Houdini won't hold the camera and take the picture for you, but you can use it as a prototyping tool if you're building like a full body character rig. So this is a quick tool I've done in Houdini, where you can just place camera procedurally or manually, or you can import camera from a previous scan, and it will project the gradient map onto a model. Then we scale it by the Fresnel. We compute the occlusion. Actually, it's very similar to a square spotlight. And then we can visualize that with the gradient. And the thing is that we accumulate the values for all the cameras in the for loop. And so you can see, okay, my setup will be like more precise on the head and a bit less precise on the hands. So you can adjust things as you want. And there is another tool using a simple raise up in a for loop. So you can just have a quick preview of the focus point for each camera. So, okay, that was for the shooting. So I'll describe how the processing of this asset, which is like an old dead trunk. And it's best to shoot in RAW because, as you can see, the goal of this presentation is to show the processing of like real life assets. Like it's not perfect, the lighting is not really even. It was actually pretty dark, so I have to use a tripod. Not far from ideal lighting and shooting condition. Not counting the spiders, actually. But yeah, it's better to shoot in RAW, and so the first step will be to develop the RAW files, like to convert them into 16 or 8-bit TIFF for the processing. And so for that, I use Houdini. So this is a tool I built using PySide and Python. It runs like NumPy for the math under the hood. And you can drag and drop a RAW file with a color checker. It automatically detects the checker, but you can place it by hand if needed. And then it computes a 3D LUT out of that will be used for the development process. And to develop the photo, I use the new top networks. So the first operator will just take a directory attribute, and then it lists all the RAW files in this directory. And then it's a Python script that runs the develop of the photos. And the last step is very important, is you need to copy the metadata from the input RAW, because it stores all the info about the focal length that are used by the photogrammetry softwares after. So if you miss this info, your scan will be less precise. So for this develop, I used OpenImageIO and Libro. And so I'm basically using the Python bindings. This Python script stop can run Houdini Python. In this case, I'm running like Python 3. So you can run the Python binaries that you want. It just works. And it's also important to note that you have a nice visualization, nice progress. You can parallelize on a form, but it can also be used as a multiprocessing framework, because Python code can be single-threaded because of the GIL. So you can just configure the scheduler to say, okay, launch as many Python tasks, as many threads you have, and so you can just use the top as it is to multiprocess your Python. Okay, once we develop the RAW, you need to run the reconstruction, so you can run it in RC standalone. You can use the Houdini plugin, or you can use the command line interface to reality capture and top network. We have a 200 million triangle mesh. So what we do is we just remove the parts we don't need, like the big trunk on the floor. We don't need this one. And we export the mesh for further processing in Houdini. This step is like super important. It's what I call pre-clean. Because out of the box, you have a mesh with a lot of details, but a lot of concavity and cavities. And you can just throw that through the RETOPO program because it won't work. So this step is very important. You can just smooth the mesh. Actually, I use a very famous PDB trick that you delete, smooth, erode to make sure the surface is really smooth and you get rid of all the tiny imperfections. And this is like almost fully automatic in Houdini. And once you have a clean and smooth mesh, you can go to the automatic retopology. So you can use instant meshes, which is an open source software, and there is a SOAP node shipped with the game development toolkit in Houdini. Or you can also use the SOAP GOZ export from the development toolkit to send it to ZBrush and use the Z remesher. In my opinion, Z remesher will work a little bit better if you have thin parts on the mesh because it has a better adaptivity. As you can see, instant meshes give like very even-sized faces, but it can miss some of the thin parts of the model. So it's up to you. If you have a complex model like that, Z remesher might be better. Then next step is the UV unwrap. And for that, you can use the new SOAP Auto UV from the GAF development toolkit. In Houdini 7.5, it has some really cool improvements, and the UV layout you can see is like fully automatic inside of Houdini. Nothing, no manual input on this one, and honestly, it worked like super well. Okay, so now it starts to be like maybe the further step. People don't really talk often about them, but you can just use this model, bring it back inside of reality capture to project the texture. The result won't be good because you're too far away from the original position of the scan. So the next step, you will need to project, to subdivide your low resolution mesh and project it back onto the raw scan. So most of the 3D scanning artists do it like in ZBrush, but the problem is that you will have subdivision artifacts because of the raycasting. Sometimes it's just overlap the mesh and project on the other side, and you have this kind of artifacts. I'm sure if some of you have already done that in ZBrush, you have already see those little guys here. So my approach is to initialize the projection in Houdini. It's a very simple graph. I use a for loop and I just do a smooth. Then I recompute the normal. Then I do a ray in both directions. And then you do it again, smooth, recompute the normal, ray it again. And it's what you can see on the right here. I start from a box. I'm projecting on the shape on the right. And you can see at each iteration, it's smoothed. And so it's a bit more relaxed. You can also use like delta mesh for that. Both will work. So I do like 3 or 4 subdivision levels inside of Houdini. Then I go in ZBrush for the last step of projection. So at this point, you have this mesh. So this is the RETOPO reprojected into on the hyperlay. And this is the raw texture projected in reality capture. So at this point, we may think that, OK, we're done, end of the day. But we're far from finished because we still miss some details on the mesh. And if you have a look at the texture, you can see that the lighting is not really even. One side of the tree was more exposed to the light because the lighting condition were not perfect. It was like quite dense forest with uneven foliage. So sometimes you can just control that. So the next step would be trying to remove the light information from the texture. We call that delighting. And what I use is, for now, is the tool from Unity, the delighting tool. It works in 2D space, and basically you provided few maps, like normal maps, bent normal maps, position, and ambient occlusion. And if you want more info about that, there is Mathieu Muller and Cyril Jover from Unity. They did a nice talk at SIGGRAPH last year, so you can watch that to have a very detailed overview of the tool. But basically, it will take the pixel of your color map, it sorts them using the normal directions, and then it can reconstruct an environment map to subtract it from the model. So I'm currently working on the CPU version of that, because the problem is that it can't process UDIMs at the moment. So I'm working on a C++ CPU version, and I will, of course, run it with top network in Houdini. Once you have a non-lit texture, you still have some parts of the scan that, for some reasons, we don't have some infos because we missed some pictures. As I said, it's real-life condition. In real life, you never have like a perfect scan. So you need to reconstruct the missing zones in the scan. Actually, there is not really a magical solution for the moment. You can use Photoshop and Mari or whatever you want and just clone stamp, copy stamp the missing areas. Maybe there will be some solution in the future using texture synthesis, like you can just synthesize the missing parts. But for now, you can just have a coffee and do that manually with a clone stamp. But these parts are also missing in the model. So we need to clean also the geometry. The actual workflow, maybe that some scanning artists do, is at this moment you have some areas of the model that are very detailed and other areas that are missing. So what you can do is you bake a displacement map of the mesh that you have at the moment. Then you select interesting zones on this map, and using Photoshop or Nuke or what you want, you can just isolate like each area, and you create a ZBrush alpha. It's just a small crop of this area fading on the side, and you will use that later for sculpting. So okay, let's see how we can automate that in Houdini. I mean, I wanted to show that because it's quite original, I think. Maybe it's not like the more revolutionary technique for 3D scanning, but we can automate this process inside of Houdini. Okay, so I haven't access to the video, but basically what's going is like I import the alpha of the texture onto a Houdini grid. So you can do it by creating a grid and then you use attribute from map, or you can do it using a COP network. And then I scatter points on the grid, and I use the UV packer node to pack some disks inside the texture. So the idea is to recreate this kind of stuff, but directly in SOP. And so then the X and Y coordinate of each point is like the center of each disk. And so then I use a top network that runs, for each point, it runs a Python task using OpenCV that just automatically generates this alpha. So sadly, I don't have access to the video, but I will try to show you maybe later. And at the end of the process, you can just use the alpha to clean the model inside of ZBrush and reconstruct the missing part. And the next part was close to finish with the asset. The next part is we do some high-pass generation from the color map. So it's quite a hack, but you can do a high-pass on your diffuse to kind of fake the very high-frequency detail. So a high-pass is just you take the color map, you make a blurred version of it, and you subtract it from the original image. This way you can remove all the low frequency, and you only have the high frequencies, and you can use them as a bump or just add them to your displacement map or use them in ZBrush. So what I do is I do 3 different levels of blur, and the 2 lower frequency level, I use them directly inside of ZBrush to project them onto the geometry. And the final frequency, I use it directly as a bump map or add it to the displacement map. And I use a Houdini COP network to do this, so it's pretty basic, but you can see it works really well using COP. And at this point, we have like a super detailed mesh inside of ZBrush, so you can then export what you have. So what's really nice is the workflow is pretty similar if you're working for game or for VFX. At this point, you have a super detailed clean scan with a nice topology and UVs. So you can export your subdivision 0 plus the displays from ZBrush. And this is basically what you'll use for a VFX shot. And you can also decimate, create your LODs, you bake your maps from the high resolution scan. You post-process them a bit, and then you have game-ready assets. For the baking, you can use the Houdini baking tools. And with tops, you can also like automate the baking in Substance if you have a Substance automation toolkit. And I personally like to use XNormal if you're under Windows, because it's a bit like the first time you open it, it looks a bit like a toy, but it's far from a toy because you can bake on CPU mode, you can bake like 1 billion polygon meshes. It just works well. So I use it when I have just super large scans. I use XNormal for the baking. Okay, so this is like the final, I would say, test renders of the asset. So you have the albedo and the beauty. And you can see the diffuse is really flat. And I added some HIVE using Houdini, but I haven't time today to speak about like the HIVE generation. Just quickly to, I also scanned the lift I used for the HIVE, and for that I used photometric-stereo. This is another scanning technique. This is more suited for surfaces or fine details. The idea is to shoot photos of your subject without moving the camera this time, but you use like a directional light and you move it from one photo to the other. You need at least 3 different like directions, but you can use way more. In practice, I use like 16 different light directions. And then you use the different lights to compute the normal map. And from this normal map and the photos, you can then compute the albedo. And you can, just from the normal map, integrate it to have quite good quality height map. So this is the classic photometric-stereo pipeline. And I use it quite a lot, and using a few different illumination modes, you can also get some roughness and specular data. And so this is basically a data set I used for the HIVE. And the cool thing is that now all this process, I implemented it in Python and C++, and it all runs using Houdini tops. Because just to quickly talk about tops inside Houdini, I'm not really a developer, I'm more a TD. And when you're a TD, you try a lot of different things. You do really quick prototyping with Python. But the problem is like coding GUI, sometimes it's like super time consuming. And sometimes you end up just running your code through the command line because you don't have time to build the GUI. And what I like in top is like you can really use it to build UI if you're a TD. I mean, you develop your code in a standard way. You test, you write your unit test, whatever you want. And inside each of these nodes, there is just few lines of code where I just pass the attributes, then I import my module, I call a function, and then it's okay. So it's really nice to use tops to quickly prototype things as a TD. And plus, you can run it on the farm. You have like parallelism out of the box, and you have also multiprocessing on a single machine if you're running Python code. So, okay, thank you. Sorry for the videos.